Hello, this is your video notes for the lecture around systems of equation inequalities. You need this for your project, and this lecture should clear up. It should clear up some misconceptions about other components of Unit 6. So we're going to go through this example, and then you're going to do an example on your own, and I'll post a key so you can check afterwards. Okay, so this is the video you're supposed to watch. The directions are to write a system of inequalities for the shaded region of the triangle below. So we have to write a system of inequalities. Oh, and then a system means that we're going to have a brace, and then you're going to write like two, three, or four, or even more inequalities, and it's going to all be part of one huge function, which is the shaded portions. We're going to write solutions so that the solutions are all the shaded part. Okay. Here are all the points. The points are going to come in handy. We have a vertical line here. There's a vertical line here. Nope, this is horizontal. Don't know what I'm talking about. This is a horizontal line. Horizontal. And as a reminder, horizontal lines are when a line is y is equal to something. So the reason why it's y is equal to something is because every single point on this line has the same y value. In this case, it's y is equal to -2. So on this green line, every single point has the y value -2. They're different x values, but every point is a -2 for the y value. Okay, now we have, let's do this. Now we have a vertical line. Here we go. Here's a vertical line. So for vertical lines, the line is x is equal to something because the vertical line has the same x value for every single point. In this case, x is equal to 4 at every single point on this line. The problem is we need to write a system of inequalities, but we currently only have equations here. We're going to fix that. We're going to use Desmos to fix that. All right, my favorite part. We are going to write an equation for this line here. When we write an equation for a diagonal line, by the way, I should remind you that, let's see. I wish the colors were here. Okay, this has a undefined slope. We don't have a number for it. Up and down is we don't have a number for it. It's like just a really, really big slope. It's undefined. And then this one, horizontal lines have a 0 slope. All right. A 0 slope. And this is going to come up more often in your math line. All right, a diagonal line has a non-zero slope and a non-undefined slope. So okay, we'll just do this one. To do this, you usually have y equals mx plus b, where this is the rise over the run, where you can literally count the rise over run if you're given a grid, or you can use the slope formula, which was y2 minus y1 over x2 minus x1, which you learned in a previous video in like, I don't know, 6.1 or something. B is the y-intercept. And in the other videos or in Algebra 1, you learned this is where the line touches the y-axis. Touches y-axis. Okay? So in this case, we don't know what the y-intercept is. I don't know. It's somewhere between 0 and 1, but I don't know the exact number. So we have to calculate it. We do know the rise and the run. You could take this point, -3, 2, and you can count 1, 2, 3, 4, 5, 6, 7, and then that's your rise, and your run is 1, 2, 3, 4, 5, 6, 7, which is not 7. I counted wrong somewhere. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I don't know. Let's find out. This is 5. This is oh no. Oh, it's because it's right here. I need a 4. Okay. This is where my point is. We're good. Let's do this. Let's take these 2 points, 3, -2, and 4, 4, and use this slope formula. So 3, -3, -2, and 4, 4. So you get to choose, are these your x1, y1 values, or are these your x1, y1 values? Pick one of these points as x1, y1, pick another one as x2, y2. If you're having trouble with this part, ask a neighbor. All right, so slope, denoted by m, is, I'll pick this one as my x2, y2. So y2 minus y1, x2 minus x1. So this becomes 6 over 7. So my slope is 6 over 7. And yes, if I count, this does become 6. The rise is 6, the run is 7. So now we have to solve for, we currently have this, y equals 6 over 7, x plus b. We need to solve for b. Oh no, if only we had a point to plug in for x and y on the line so we can solve for b. If only, oh look, we have so many points. Let's use either 4, 4 or -3, -2. Let's do the 4s. Let's not deal with negatives. All right, so I'm plugging in, I had a point, 4, 4. So my x value was 4 and my y value is 4. So here I plugged in x for 4 and y for 4. Here we go. We're going to do some subtracting. Nope, we're going to do some multiplying. And now we're going to do some subtracting. All right, 4 minus 24 over 7 is actually, let's make it a common denominator. 28 divided by 7 is 4. And then 24 over 7 is equal to b. So we have 4 over 7 is equal to b. So your y-intercept is 4 over 7. Now, what does that mean? 6 over 7, x plus 4 over 7. Let's graph these beautiful equations on, let's graph this one, and this one, and this one. Let's graph them on Desmos. And then I'll show you how to play around with the inequalities, which you can use for your project. So you can figure out which way the shading goes. So when you go on Desmos, you can just watch for now and then play on Desmos. Type in Desmos. All right. So we have y equals 4. We have we have y is equal to -1. X is equal to 4. And y is equal to 6/7 x plus 4 over 7. Doesn't that look like our triangle? Doesn't that kind of look like our triangle on our paper? Kind of, except we need to start shading in the triangle. So right here, if you delete the equal sign, you can put in one of these 4. You can put in one of these 4 inequalities. These 2 inequalities mean that you have a dotted line, and these bottom 2 inequalities mean that you have a solid line. So say you just want to punch in one, you just want to try out this less than or and equal to inequality. Unfortunately, the less than and equal to inequality shades below the y equals -1 line. We don't want that. We want to shade above the y equals -1 line because we want to look like we want to shade above this line. Okay, so what we do is we go back here, delete it, and then, oh, now we shade above. Let's do the same thing for this equal sign. You can either shade above or below or less than or greater than. Okay, so we shade less than. So notice the blue and the red is making a purple. That's good. We want all the where all the colors are going to mix is where our solutions are. Okay, so this became less than, and then you just kind of guess here. You can either pick this one. You're like, that's not right. It's dotted. This one, oh, that's right. The green is overlapping the red and the blue. Notice if you change to this one, you're like, oh no, my green is not overlapping where I want it to overlap. So this one. Okay. Ta-da. The last thing you have to do to write a system of inequalities is literally copy this down. Whoa, that was really loud. So all you have to do is copy it down. Whoa, why not? Okay. So I don't know if this will. Let's just write it. So your system of inequalities is Oh, brilliant. Look, it's right here to my left. Y is greater than and equal to -1. X is less than and equal to 4. And Y is less than or equal to 6/7x plus 4/7. Ta-da! Um, we are going to I'm going to stop this video. I want you to try out this you try part, and then I will post the answer key. The answer key is important because this is actually how you do your project. So down here, once you find your system of inequalities, which I don't remember what it is right away. Actually, yeah, I'll post the answer key. But this part 3, is really important. It says, using the following characteristics of a parallelogram, prove that the shape is indeed a parallelogram. This is a common part of your project where you have to prove a shape is a certain shape. And so in this case, you're proving that a parallelogram is parallelogram by saying the opposite sides are the same length. So you're going to need distance formula. And you need to prove that both of the pairs of opposite sides are parallel. So you need to prove that this line is parallel to this line, use the slope, and this line is parallel to this line, use the slope. And you have to write that on there, and that's part of your project. So I'm going to post this answer key. If you have questions on this one, go ahead and email me or ask a neighbor to help you out. Okay, bye. That's the end of this video. That's the end of your notes. I'll put the answer right here. Bye.